Good morning, our dear cherished listener, and welcome to our today's class. Today we are still discussing the concept of trigonometry in mathematics and statistics, especially as it concerns the basic trigonometric ratios and identities, and most importantly, the Pythagorean identities. There are questions we have come up with, which we intend to solve with you this morning, in a way and manner that will equally have you impressed about the concept of mathematics and trigonometry. We encourage you and plead with you to do one thing for us, to subscribe to our YouTube channel so that we'll be able to be getting our classes the moment we upload them. We equally encourage you that once you have a challenge, especially as it concerns the approach that we give to problems when we are solving them, raise your concern in the comment section. I assure you that the moment we come across them, will definitely come to your needs. The essence of this class is to make sure that we remove in you the fear you have about these subject matters, mathematics and statistics, and be able to gradually develop the love in you about or towards these subject matters. So without wasting much of your time, let us have these questions written on the board. Solve them with you, and I assure you, you are not going to regret being part of the class. The question says, and I write, if tan theta plus sec theta equals 4, find the value of cos theta. I write it on the board. That is question number 1. They say if tan theta plus sec theta equals what? 4. Find cos theta. That is the question that is given to us. As a way of solution, I will come here and write solution. The first thing you are required to do when you are given a problem like this is to think of an identity in trigonometry that relates tan and sec together. And the only identity that relates tan and sec together is the second Pythagorean identity. So another test of your ability to solve this problem is for you to be able to recall the second identity of Pythagorean that relates tan theta and sec theta together. And that identity says, and I write, that tan square root theta plus 1 equals sec square root theta. That is the second identity of Pythagorean. So the moment you can recall this identity, you may be able to jungle your way out of this problem successfully. And of course, when you have this, you can write this thing this way. That tan square root theta, bringing this sec square root theta over here, it takes a negative sign, minus sec square root theta, taking this 1 over there, when it is bearing positive sign, it takes a negative sign. So you have what? Minus what? 1. If you must make this minus 1 to be positive, it means that you need to use negative sign to multiply all through. And using negative sign to multiply all through my left-hand side, I'll be able to have this written this way. That sec square root theta minus tan square root theta is given as what? 1. At this point in time, we are going to record something for ourselves. You remember that the difference of two squares or difference of squares is written as a raised to power 2 minus b raised to power 2 is given as what? A plus B, open again, A minus what? B. You remember this. And if you can remember this, of course, we return back here. We are looking at sec square theta as if it were A raised to power 2. We are looking at tan square theta as if it is B raised to power 2. And on that note, we can express this the way we express this one. So I will now say, therefore, what I have here becomes sec theta plus tan theta, open and close, open again. I have sec theta minus tan theta equals what? 1. That is now what I have now. Of course, when we look at this problem, we find out that we have been given that tan theta plus sec theta is given as what? As 4. And when you come down here, you are seeing sec theta plus tan theta. Because whether this one comes first or this one comes first, as long as the sign here is positive, nothing changes. So they have told us that sec theta plus tan theta is given as what? As 4. So in place of this sec theta plus tan theta, I am free to use what? 4, in as much as this is equal to that. And what I have now becomes 4 in place of this, 4 times. I have what? Sec theta minus what? Tan theta equals what? 1. Then you open and close, showing that this 4 is multiplying what? 2. Of course, you are seeing this 4 as if it were the coefficient of this sec theta minus tan theta. So if I want to make sec theta minus tan theta to stand all alone, I am going to divide both sides of the equation with what? With 4. And then in that case, I'm going to have all over 4, all over 4. So that this 4 can cancel this 4. And what I have becomes that sec theta minus tan theta is given as 1 over what? 4. This is now what I have. When I have this in this way, I can equally come back and look at here. You still remember that my tan theta, look at I have tan theta here. You still remember that my tan theta plus sec theta is equal to what? 4. So I can make tan theta subject of formula here. And making it subject of formula here, what I have here becomes that my tan theta equals, here is what? 4 minus what? Sec theta. So I can easily come back here, wherever place I see tan theta, I will remove tan theta and replace with 4 minus sec theta. And then I will now call up this thing to solve with you. The beginning of what I have here is sec theta, so I will write sec theta. That is what I have here. The sign here is minus. I will write what? Minus. What I have here is tan theta. Well, I'm no longer working with tan theta. I am working with its equivalent, which is 4 minus what? Sec theta. So I'll open a bracket and put 4 minus what? Sec theta. This is equals what? 1 over 4. So I have that this is equals 1 over what? 4. I want to open a bracket by letting this minus come into this bracket. So what I have here becomes that sec theta minus what? 4 plus. Because when minus multiplied by minus plus, sec theta is given as 1 over what? 4. Then I will now return back here. Sec theta plus sec theta is 2 sec theta. So I have that what? 2 sec theta is given as, here is 1 over what? 4. When this 4 goes over there, then I'll be able to have what? Plus what? 4. Because this 4 is carrying negative. When it goes to equality sign, it changes to positive, and I have this to be this. I can add these things up by saying that all over 1 doesn't change anything. Then I'll ask myself, what is the LCM of 4 and 4? LCM of 4 and 4 is what? 4. I'll write 4 here. 4 divided by 4 is what? 1. 1 times 1 is what? 1 plus. 4 divided by 1 is what? 4. 4 times 4 is what? 16. I have what? 16. So what I have here becomes what? That 2 sec theta is given as what? 17 all over what? 4. And remember that what I have here is 2 sec. So I can make this sec to stand all alone by dividing both sides by what? With 2. So I'll be able to have all over 2, then here becomes divided by what? 2. Permit me to clean here and be able to complete the solving there. So this is where we began. First of all, we were told that tan theta plus sec theta is what? Is 4. We are required to find cos theta. We think of an identity that relates tan theta and sec theta together. That identity is this. That tan squared theta plus 1 is sec squared what? Theta. Then by rearranging this, we arrived at this. And by recording difference of 2 squares, we had this. And looking at this is the 2 squares now, we equally express it as what? As this. And when we express as this, we realize that what we have here had been given to us here now to be what? To be 4. So in place of that place now, I will replace what? 4. And then trying to make this one to stand all alone, I divide both sides by what? By 4. And I had this. And when I had this thing, I came back here and reminded myself that tan theta plus sec theta is equal to what? 4. And therefore, I can make tan theta subject to formula, which becomes 4 minus what? Sec theta. Bringing that value of 4 minus sec theta now into the place of what? Tan theta, I have this. And when this negative goes in there, I have this. And sec theta plus sec theta will give me 2 sec theta. And here is 1 over 4. Bringing this minus over 4 here now, I'll have plus what? 4. And then finally, the LCM of 4 and 1, I have it to be 4. And evaluating, I had it to be what? 17 over what? Over 4. I'm trying to make sec theta to stand all alone. I'm going to divide both sides with what? With 2. So that this and this can go. And I have that this is 17 over 4 divided by 2. So permit me to clean this top here. Permit me to clean this top here. So what I have here becomes that sec theta is given as, when I change this division sign into multiplication sign, the numerator comes down and the denominator goes up. And what I have becomes what? 17 all over 4 multiplied by 1 over what? 2. This equals 17 times 1 is what? 17 all over. 4 times 2 is what? Is 8. So I have that sec theta is what? 17 over what? 8. But the question we are asked to find is what? Is cos theta. But the only thing we know is that 1 over sec theta is what we call cos theta. So I will now come here and say, for me to find cos theta, I will now say that 1 over sec theta, 1 over cos theta is what? Sec theta. 1 over cos theta is sec theta. So I have but 1 all over sec theta. 1 over cos theta, sorry, is equals what? Sec theta. So trying to make this cos theta subject of formula, I say all over 1. I say cos theta times sec theta is cos theta sec theta. This equals 1 times 1 is what? Is 1. But I know that my sec theta is already 17 all over what? 8. Okay? So which means standing this cos alone, I will now say cos theta multiplied by sec theta is what? 17 over 8, 17 over 8. This equals what? 1. Of course, this is multiplication. And when it crosses this equality sign, it becomes what? Division. So keeping this cos theta to stand all alone, what I have here is what? Cos theta is given as 1. This one here divided by what? 17 all over what? 8. So that I will be able to have 1 multiplied by 8 over what? 17. Which is what? 8 all over 17. So 8 over 17 is our answer. Of course, they gave us so many options. They gave 8 over 17, they gave 17 over 8, they gave so many things. But the correct answer there is 8 over 17. That is the value of cos theta. Thank you very much for your steadfastness in our class. Thank you for raising your concern, even for raising your concern in the comment section, where you do not understand, surely we come to you. This class is meant for you, and it is meant to have a change positively in you about the subject matter, mathematics and statistics. Thank you very much. We really want to believe I didn't have much problems here. So what we are going to do is to clean the board, call up another question, and be able to solve together with you. Thank you very much. The second question says, and I read. The second question says, and I read. If sine theta plus cos theta equals 7/5, what is the value of cos theta? If sine theta plus cos theta equals 7/5, what is the value of cos theta? That is the question they ask us there. So I'll write number 2. That's number 2. If sine theta plus cos theta equals 7/5, find sine theta cos theta. They say if sine theta plus cos theta is given as 7/5, we should find the value of sine theta cos theta. That is sine theta multiplied by cos theta. When we have a problem like this, the first thing we are going to do is to equally look for an identity that connects sine theta and cos theta together. And the identity that connects sine theta and cos theta together is the first Pythagorean identity. And that the identity says, and I write. So by way of solution, I have solution. That identity says that sine square root theta plus cos square root theta equals what? 1. That is what the identity said. But unfortunately, when we look at this identity, we cannot see anything close to that in this question. So what we are going to do is to see whether we can modify this question they gave us, to see whether we'll be able to see this kind of identity after the modification. The modification we mean here, first of all, could be by squaring the left-hand side and equally squaring the left-hand side. And when I square the left-hand side and then the right-hand side, I will be able to have something like this. I will have that sine theta plus cos theta, open and close, all squared, is given as what? 7/5. Then all raised to power what? 2. And of course, this square can be written as the sine theta plus cos theta, open and close, open again. The sine theta plus cos theta is given as, of course, 7 squared is what? 49. And then 5 squared is what? 25. This can be expressed as this. Our effort is to see whether after this modification, we may be able to have something that looks like the first Pythagorean identity. The moment we do, the problem will be easier for us to handle. Then when we have something like this, we multiply out, or we say we open the brackets. This sine theta will multiply sine theta. This sine theta will multiply cos theta. This cos theta will multiply this sin theta. This cos theta will multiply this cos theta. And what I have here becomes, when sin theta multiplied by sin theta, I have sine squared what? Theta. The sign here is what? Plus. When sin theta goes into this, I have what? Sine theta cos theta. The sign here is what? Plus. When this cos theta multiplied by this, I have cos theta sine theta. The sign here is plus. When this cos theta multiplied by this cos theta, I have cos square what? Theta. We are told that this thing is equals to what? 49 all over 25. What do we do next? Everything here are positive signs, no one is negative. So I have sine square theta plus cos square theta. Let me bring close all of those that contain square. So I will be able to have that sine square what? Theta for this plus this one cos square what? Theta plus. Here is sin theta cos theta. Here is cos theta sin theta. They mean the same thing because you are talking in multiplication. In multiplication, if cos comes first and sin comes behind, or cos comes first and sin comes behind, it does not affect anything. It's just like saying 1 over 2 times 3 and 3 times 1 over 2. The answer is the same thing. So this quantity and this quantity is the same thing. Because that this quantity is this quantity the same thing, it just becomes this plus this, which will give me 2 of that. So what I have now becomes what? 2 cos theta sin theta. This equals what? 49 all over 25. Of course, when we look at here, I have sin theta square plus cos theta square. And when we look at the first identity of partogram, that identity says that sin square theta plus cos square theta is given as what? 1. And what I have here is sin square theta plus cos square theta. So in place of this, I can use what? 1. That is the essence of this identity. So what I have from here to here becomes what? Here is what? 1 plus. What I have here is what? 2 cos theta sin theta is given as what? 49 all over 25. This one and this are like terms and should be collected together. So this one will go over there. And this one going over there, what we are going to have here becomes what? 2 cos theta sin theta is given as what? 49 all over 25 minus what? 1. You can say 1 all over what? 1 without changing anything. So what is the LCM of 25 and 1? The LCM is what? Is 25. So I have what? 25. So I have 25 divided by 25, 1. 1 times 49 is 49 minus. 25 divided by 1 is 25. And 25 times 1 is what? Is 25. This equals 49 minus 25 is 24. So I have 24 all over what? 21.5. That is what I have there. So by implication, you are saying that 2 cos theta sin theta is given as 24 all over 25. We are becoming happier because we are looking at finding sin theta cos theta. And once we look at here, we're already having cos theta sin theta. And like I earlier had mentioned, if you have cos theta sin theta, it is the same thing like a sin theta cos theta. Because they say multiplication is commutative. It comes this way or it goes the other way, the answer returns the same thing. So you permit me to clean this top here while we finish resolving this. But before I clean it, let us rehearse in the much we have done. We were told that sin theta plus cos theta is 7 over 5. And we were asked to find sin theta cos theta. The first thing we did was to think about an identity that connects sin theta and cos theta together. And we noted that the identity is the first identity of partographs, which says that sin square theta plus cos square theta is given as what? 1. But unfortunately, we looked at this identity and looked at the question we were given and we couldn't see any relationship. And because we could not see any relationship, we said that we needed to modify this question they gave us. to see if after the modification we'll be able to have something that looks like this an identity. And when we did the modification we chose is to square the left-hand side and then the right-hand side. And that led us to say that sin theta plus cos theta raised to power 2 equals 7/5 raised to power 2. And after expanding this bracket, we arrived at this. And squaring this, we arrived at 49/25. When we multiplied out these brackets, we arrived at this quantity, which is 49/25. When we collected like terms, or when we collected those having squares, then we have that sin squared plus cos squared, because look at sin squared theta here, look at cos squared theta here. So we brought them together. Plus, this and this are the same thing, 2 cos theta sin theta. This equals 49/25. It was at this juncture that we now looked at our identity and we saw something that is the same as our identity in the expression we have. The identity says sin squared theta plus cos squared theta is given as 1. What I have here is sin squared theta plus cos squared theta. So I can let go of the whole of this quantity and replace with 1, in as much as this 1 is equal to this. That was why I had 1 here. Then this 1 and this 49/25 being like terms and being collected together, then we arrived at what? 24/25. So permit me to clean here and we complete our solving here. So permit me to clean here. So what we now have now becomes that 2, we have that 2 cos theta sin theta is given as 24 all over 25. That's what we have. And of course, for us to make this cos theta sin theta to stand alone, we divide both sides with the coefficient of cos theta sin theta. So we have all over 2, then divide by what? By 2. You can see divide by 2/1, it doesn't change anything. So that this and this can go, and you have that cos theta sin theta equals, here is 24 all over 25. When you change division sign into multiplication sign, then the numerator goes up, the numerator comes down, and the denominator goes up. So multiply by 1 comes 1 all over what? 2. Here I have 2, 2 can go into 24. So 2 here is 1, and 2 into 24 is what? 12. So this thing becomes what? 12 all over 25. And that becomes our answer. So situation whereby you are given that this quantity and this quantity is equal 7/5. And then you are asked to find this and this. When you follow this process or procedures, definitely you are going to arrive at something that is an answer. What are we trying to let you hold or pin down in this class today? That when you are given problems that has to do with tan and sine and the rest of them, make effort to be able to remember all the identities we have in trigonometry, especially the Pythagoras identities, the first, the second, and the third Pythagoras identities. We still believe that you have not had a challenge. If you have, please, we are pleading, drop your comments or drop your concern in the comment section. We equally plead with you. Encourage us, motivate us to always come before your doorstep, knocking with the knowledge of maths and statistics by subscribing to our YouTube channel. Let us clean the board and call up another question and still solve with you. Okay, this question says, and I write, it says if P equals cosec theta minus cot theta, and Q equals cosec theta plus cot theta inverse, Which of the following is true? Look at the question. The question says, if, let me call it question number 3. Say if P equals cosec theta minus cot theta and Q equals cosec theta plus cot theta inverse. Which is true? Which of the following? Is true? A, P minus Q equals 1. B, P minus what? Q equals what? 3. C, P plus Q equals 1. And D, P equals Q. Look at the problem they gave us. They say if cosec theta minus cos theta, if P equals cosec theta minus cos theta, and Q equals cosec theta plus cos theta inverse, which of the following is true? That P minus Q is equals to 1. That P minus Q equals 3. That P plus Q equals 1. And that P is equals what? Q. Let us see whether at the end of solving this problem, we may be able to get something that is like this. So the first thing we are going to tell ourselves is this. What is that identity that connects cosec and cot? The identity that connects the cosec and the cot is the third identity of Pythagoras that says that 1 plus cot square theta is equals cosec square theta. That is that identity. I'll write it on the board. So as a way of solution, I have that identity says that 1 plus cot square what? Theta equals cosec square what? Theta. That is the third identity of Pythagoras. It says that 1 plus cot square theta equals cosec square theta. And when you have something like this, of course, you can rearrange. By a way of rearrangement, you can write this into B that here it becomes, when you bring this cot over here, you have that 1 equals cosec square what? Theta minus cot square what? Theta. This can be written like this. And if this can be written as this equally can be written as this. That this is cot square what? That this is what? Cosec square what? Theta minus cot square what? Theta is given as what? 1. This and this, the same thing. I didn't change anything. And because this is this, we equally remind ourselves what we call difference of two squares. And that difference of two squares says that A raised to power 2 minus B raised to power 2 is given as what? A plus B into A minus what? B. So I can apply this principle here. And what I have here becomes that cosec theta plus cot theta, open and close, open again, that cosec theta minus cot theta equals what? 1. Okay? But we have been told that cosec theta minus cot theta is P. We have been told this. that this minus this is P. So look at it here, that cosec theta minus cot theta is given as what? P. So I can quickly in place of that put what? P. And if I put P, what I'm going to have becomes that my cosec theta plus cot theta open and close. In place of this, I will put what? P. This equals what? 1. Of course, this my P is multiplying everything this way. So if I want this one to stand all alone, this P will divide both sides. And I'll be able to have all over P, all over P. This P will cancel this P. And what I have becomes what? That cosec theta plus cot theta is given as what? 1 all over what? P. 1 all over P. So this is what we have. But then when we look at here, we are told that our Q is given as cosec theta plus cot theta inverse. So if I must have to find my P, my Q, I will now say this quantity here raised to power minus 1. And let us check what they have here. What I have here is cosec theta plus cot theta. What they have here is what? Cosec theta plus cot theta. So what I have here and what I have here is the same thing. But they are telling me that what I have here is 1 over P. So if I want to find my Q, it is going to be 1 over Q, 1 over P raised to power what? 1. So which means I will now come here and I will now come and say that my Q here, my Q, which is what I have here, is equals. What I have here is what? Cosec theta plus cot theta. The answer is 1 over P. What I have inside here is what? Cosec theta plus cot theta, which is 1 over 2. So I will now come here and say 1 all over what? P. All raised to power what? Minus what? 1. And of course, we know that anything raised to power minus 1 means 1 over that. So this becomes that my Q is equal to 1 all over 1 over what? P. And 1 over 1 over P means you are saying 1 divided by 1 over what? P. Because this line is a division sign. And then this becomes 1 multiplied by P all over what? 1. And then this 1 times P is what? P. P divided by 1 is what? Is P. Therefore, you have that your Q is equal to what? Your P. So meaning that our answer is what? Is D. So they can give somebody something that is a bit challenging this way. It requires you the knowledge of recalling as many identities as possible. Okay? We are equally going to come up with a lot more questions on trigonometric ratios and trigonometry. Do remember that we are still discussing on Pythagoras identities. And we said and promised earlier that on the course of our study on trigonometry, we are going to look at Pythagoras identities, look at sum and different identities, then look at double angle identities. So in our next class, we are going to factor in these sum and different identities and double angle identities. Discuss it with you, just like we discussed these Pythagoras identities with you on our first class on trigonometry. So situation whereby you are still finding it difficult to recall these Pythagoras identities, please, we plead with you, visit our first class on trigonometry, tagged a class on trigonometric identities or on trigonometry 1. Go to our YouTube videos, look for a class that is talking about trigonometry. Go through it now and be able now to see some of the things that were established there that day. So as a way of emphasis, I am going to clean the board, write these identities equally down, and plead with you to pick up your jotter and write down these identities so it can help you to recall them. I quickly write the identities, the Pythagoras identities here. The Pythagorean identities. Yes. The Pythagorean identities. Pythagorean identities. Number 1 says that sine square root theta plus cos square root theta is given as what? 1. Number 2 says 1 plus cot square root theta is given as cosec square root theta. Number 3 says that tan square root theta plus 1 equals sec square root theta. These are the 3 major Pythagoras identities which I want you to remember and hold very firm in your hand. Thank you very much for your audience this morning. We still plead with you, stick around with us as we continue to bring these classes to you. I assure you, before in a while, you look at yourself and begin to ask questions. How and where did this transformation in your life about this subject matter come from? Do remember that with consistency and persistency in anything, nothing is difficult. You can know maths and statistics very, very well. And then the world will come to hear your name about them. Thank you very much. We hope to see you again in our next class. Follow us, subscribe to our YouTube channels. Thank you very much.